Hey everyone, today we're going to be doing a question from elements of the programming interviews in Python called Is Tree Balanced? So here we're going to be getting a binary tree and we're going to be checking if it is balanced or not. To check our solution, we're going to be using the EPI judge, and for that you will find a link in the description. So our assumption here is that the definition of a balanced binary tree is a tree that has a height difference at most 1 on each side. So the way we're going to do this is we're going to use a helper function. So for instance, if we have a tree that is 1 with children 2 and 3, we're going to return true. And then if we have a skewed tree like 1, 2, 3, where all the children are on the right, we're going to return false because the difference of height here is on the left it's 0 and then on the right it's 2, which is a difference greater than 1. And note if we had something like a 4 here, that would also be a true simply because the height difference is still 1 here. So the way we're going to do this is we're going to define a recursive helper function, and we're going to go level by level, and this helper function is going to return if the subtree is balanced, but it's also going to return the maximum height at that tree. So when we go down here, for instance, any leaf node by default is going to be true and is going to have a height of 0. And then as we go up, we're going to say, okay, this one has a difference of only 1 and it is balanced. So that's fine. Then we're going to go down to this 2. We're going to see it has a height of 0. It's going to be fine. It's going to go up. It's going to have a height of 1. These both have a height of 1 and 2. The difference there is 1, so we're going to return a true here. So let's see this helper function. We'll say def helper, and it's going to take in a tree node, and we're going to say it returns a tuple, which is going to be bool int, and it's going to be true if subtree is balanced, and returns height of subtree. So by default, if we don't have a node, we're going to say if not node, so we're at the null case. We're going to return true, and we're going to return -1 because no tree does not have any height, and -1 is going to be the default for that. So otherwise, we're going to check the left tree and the right tree. So we're going to say left balanced, left height equals helper of node dot left. We're going to say right balanced, right height equals helper node dot right. And then what are our conditions? We need both trees to be balanced, and we need the height to have a difference of maximum 1. So we'll say if not left balanced or not right balanced, or if the absolute value between the differences in height is greater than 1, then we're going to return false. We're going to return false, and then we need some random number to also fill just to make sure that our return is correct. We're going to say -1 as well. Otherwise, we're going to return true, and then we're going to return whatever the bigger height is. We're going to say left height, right height. We're going to take the max of that, and then what are we going to do? We're going to add 1 because we also want to include the current node that we're at. Then how are we going to return this? How are we going to take advantage of this helper function? Well, we're going to say our answer is going to be only the bool value. So for our final answer, we don't really care about the actual height. We just want to see if the root fully recursively down is balanced. So we're going to say return helper of root, and we only need the first entry of that tuple, so the 0th entry. So to review, if we're going to go through one of these examples, if we choose this first one, for instance, 1, 2, 3, so we're gonna call the helper on the root. We're gonna see that we need to do a left recursive call. This recursive call is going to return, for these ones, it's both going to return -1, -1. So here it's going to be a height of 0. It's going to return true 0 here. Then as we recurse down this one, the children here are going to be -1, -1, both true. With the 4, it's going to be 0. On this side, we're going to compare -1 and 0, both true. And we're going to come back up here with the result 2 versus 1 also works, and we're going to finally return true. However, in this function, we're going to recurse down. Here we're going to have true 0, or true -1, then true 0, true 1, true 2. But on the left side, we only have a 0. So 0 and 2 is going to return false because the difference there is more than 1. And then finally, we're going to return false. So let's test out our solution. And it looks like we missed something. Is our first, oh, it's true. Okay, so our initial variable is called tree, not root. So we should fix that. And as we rerun the test case, we pass all of our test cases very quickly, and we do so with a runtime of O of n. So we have a runtime of O of n, since we are visiting every single node in the worst case, and our space complexity is O of height, where height could be O of n in a skewed tree, or in the average case is usually O of log n, simply because at each point we need to maintain the stack for the helper function. Anyways, this concludes the question, is balanced binary tree. I hope you enjoyed this video, and if you did, please like, comment, and subscribe. And if you're interested in interview help, you can book an appointment on our website or fill out the Google Docs, and we will contact you shortly. Thank you for watching, and have a great day.